All right. Thanks everyone for coming today, and I'm excited to talk through Gloo 1.4 in this webinar. As Betty mentioned, I'm the Director of Engineering, so I work with the engineering team at Solo. And so today we're going to kind of go through, we'll do a brief background on what Gloo is if you're relatively new to it, and then we'll go through some of the broad strokes and the kinds of features that got into 1.4. And then towards the end, I'll specifically go through two demos that I think are pretty interesting and that I'm excited to share today. Oops. So just as a little bit of background, if you're new to Gloo, Gloo is an API gateway, and an API gateway conceptually is a piece of infrastructure that is meant to essentially deal with challenges that have emerged from modern digital transformations. So when we started, it was kind of the trend was migrating away from monolithic systems to microservices. We've also seen kind of an explosion of other cloud services, maybe things like Lambda that entail that allow you to build serverless applications, and generally just kind of the emergence of cloud, the emergence of containers and orchestrators, and things like Kubernetes has just led to the desire to solve some of these problems that these transformations entail through new infrastructure. And the gateway specifically is solving those problems that you have kind of at the edge of your application. So whatever your topology is, if you kind of draw a box around it, somehow you need to be connecting users to your application. And in doing so, you want to be thinking about how you're managing APIs and connecting to your services, while also kind of enforcing security, protecting your application against potential malicious attacks, and generally observing what's going on, making it easier to manage and operationally control your application. So Gloo is our implementation of that concept of it's an API gateway. The Gloo, the conceptual version of Gloo is kind of highlighted here on the left-hand side. So Gloo consists of first Envoy. Envoy is the actual proxy, the actual process that sits between users and the services, as shown here in this picture. And then Gloo adds a bunch of services on top of that called a control plane, whose responsibility is dynamically reconfiguring Envoy. Envoy was ideally kind of designed, it was designed for this use case. There's a protocol called XDS. It's very easy to push configuration to it. And it's got a very large configuration surface area. So having a control plane that simplifies that is really advantageous. In addition to Envoy, there are some key kind of characteristics of Gloo. One, we're cloud native. So we kind of designed from the ground up with kind of the new cloud primitives, new Kubernetes primitives in mind, meaning that Gloo is stateless. It's backed by CRDs if you're deploying in a Kubernetes environment. But we did abstract it in a way that you can deploy additionally in kind of hybrid environments where maybe not all of your application is on Kubernetes, as well as totally non-Kubernetes environments. So we have some customers running in production with where they're storing config not in Kubernetes' etcd database, but in HashiCorp's console. We've built abstractions to handle these kinds of cases. And finally, there's kind of a minimal infrastructure footprint, and we really like to highlight the fact that this is true at scale. So we've decoupled components, we decoupled the control plane from the data plane. If we need to scale up our kind of throughput into our application because we've gotten a bunch of new users, we can just increase the replica count. Gloo knows how to configure multiple envoys just as easily as a single one. And the same logic holds for different control plane components. So we've really been thoughtful about how this will work at scale. The other kind of consideration that we put a lot of thought into is kind of extensibility, and how do we get that last mile customization for the next customer is really kind of often bespoke production environment. And so we've kind of built every aspect of Gloo is pluggable. So if it's just exposing a new Envoy config to users, we can easily add that into our Gloo configuration. But we've also kind of been thoughtful about building plugins for auth and for even customizations to Envoy itself as we'll see in the demos a bit later. There's a number of companies using Gloo. This is just the logos that we pulled from our website. Really would encourage you to get a better sense of how Gloo actually behaves in the wild. To look at our website on the customers page, there's a number of quotes and case studies and just like pretty interesting content out there. There are also a couple of blog series that really kind of highlight how Gloo fits into the bigger picture, you know, on production ops teams' kind of platform. And of course, in addition to the companies using Gloo, we've got a pretty large open source community. So in addition to looking at the website, would highly encourage anyone that's interested in kind of using Gloo to join that community, join our Slack, jump into some of the channels for Gloo and other things. And I think we have over 1,000 people in Slack right now. So there's a big community there that we are also gathering feedback from. So that's it for background on Gloo. Now, what did we do in 1.4? And before getting into the specifics, just want to remind people about our release model. So we released 1.4 at the end of June to follow kind of our quarterly stable release process. So the previous release, the previous kind of stable big enterprise release was 1.3 that happened at the beginning of April. And we'll be continuing on this quarterly cadence for our kind of minor version bumps. So 1.4 represents basically 3 months of work for the team. And a lot of that work was prioritized really based on kind of the feedback that we've been getting from a growing customer base, as well as I was mentioning, a growing kind of user base in our open source community. Some highlights include some scalability improvements. In addition to kind of like improved support for the Kubernetes Ingress spec, we had a user report that a show-stopping issue where we couldn't really support multiple Ingress classes with Gloo, which we kind of worked through and fixed, and now we've got much better support there. Similarly, Istio released a 1.6 version, so we kind of added support and along the way kind of made some improvements to how we interact with Kubernetes. I'll come back to the security enhancements because that's going to be part of my demos, but we also made a number of improvements just in terms of the developer and the ops experience. We're really kind of trying to be thoughtful about listening to feedback along the lines of either configuration that makes it hard to manage and upgrade Gloo over time. So if this is Helm values or other things that we need to do to just minimize the operational overhead, as well as, you know, incorporating Gloo into CI pipelines. We've kind of made some progress on making it easier to validate config before it goes in to the cluster and so forth. And finally, we've exposed a bunch of new configuration options. These are probably the easiest things for us to do because of the architecture of Gloo that I was mentioning before. So for example, when Envoy kind of incorporated a buffer filter, we were very easily able to just wire that up in Gloo config. I will note that for a broad summary of this, Betty and the team have published a blog. So I would check kind of a blog for links to all the specific pull requests and kind of context behind these things. I mentioned Ingress, but actually I mentioned these kind of already with these, I just wanted to kind of reemphasize that we've done a lot to kind of make Gloo work more seamlessly with both native Kubernetes objects and service meshes, which is kind of, you know, we're kind of working with the community who's kind of been adopting these as they go. We're going to get to some other security improvements, but it's worth calling out. We've made some enhancements to how things are audit logged. So we have a WAF filter that's been working part of Gloo for enterprise for really probably about a year now, but it was a little bit lacking in terms of the logging and the audit logging. So we've done some work there based on feedback that we got. Similarly, kind of done some work to make it easier to manage kind of MTLS between each of the components of Gloo, you know, whether it's between the control plane services or between Gloo control plane and Envoy the data plane. And here again, we're just kind of listing, I touched on these already, made a number of improvements to the kind of developer experience. One that's worth calling out, kind of maybe more specifically than I said, validation's always been we've always worked hard to prioritize kind of making it clear when there is a problem. But an area that was particularly challenging with this was validation of transformations, because the transformations use a template language called Injo, which is really hard to proactively detect when there's a problem. You really kind of need to try it and see. And so what we did instead is we kind of made it possible through GlueCTL improvements to actually deploy kind of a trial config to a trial Envoy and actually test it for real. So, this is the kind of thing that, based on feedback, we realized this was a very particularly painful point of configuration and of iteration, which we focused on optimizing. And just to highlight a couple other things, as I mentioned earlier, one of the big selling points for Gloo is to enhance the observability story on all the traffic that's going into the cluster. One way that we do that is through offering with Enterprise Gloo some auto-generated dashboards and some pre-built dashboards that we provide that just make it really easy to see what's going on through the proxy. And we've done some work to improve the management of those this last quarter, both in terms of surfacing more specific metrics that we can rely on to really understand kind of performance in the proxy and the cost of running Gloo, as well as just making it more manageable to maintain those auto-generated dashboards. This was really a pretty minor kind of summary. We'll come back to this page, but there's a lot more information on the website. So if you're curious about any of the features that I kind of touched on, would just recommend you look at the blog, and that will have links to the specifics. But at this point, I want to shift gears and highlight two specific features in 1.4 that you can now use today. Oops, I stopped the share. Let me get that back. Great. And I'm going to be demoing largely through this VS Code window. So Betty, please chime in if this is like hard to follow or hard to read. I tried to make it larger so that you could see what's going on.
The font size looks great.
Cool. Okay, so the first thing that I would recommend, if you haven't updated GlueCTL in a while, oops, the first thing I often do when I'm coming back to Gloo after a while is do a GlueCTL upgrade. It's an in-place upgrade, so it basically just grabs the latest stable release. For us right now, that's 1.4.5, so that'll be a nice starting point. That means by default, it's going to install 1.4.5. Now, the first demo that I'm going to go through is about WebAssembly. So I want to provide some background to what this is. WebAssembly, as you might be aware already, was a technology that kind of emerged for the browser as a way to make it easier to develop complex multi-language, polylanguage applications and be able to run, compile them down into a common runtime and then actually just run them. And WebAssembly has been kind of around for a few years. Has been gaining steam with respect to browsers. Every browser has some kind of native support for it at this point. More recently, the Envoy community has seen it as a kind of a mechanism that could enable customization, lowering the barrier to entry of customization of the proxy. Just get a sense of what that means. We build some custom filters for Envoy into our kind of enterprise Gloo Envoy wrapper. In order to build those, we've basically kind of compiled against mainline Envoy, something near master, and then we've packaged up our extra filter logic. We had to write it in C++ in a particular way that agreed with the compilation process for Envoy. And then as we need to do new releases or update APIs or whatnot, we'll kind of do full release processes of that wrapper. So this isn't impossible, but it is fairly cumbersome of an extensibility story, if for no other reason than the fact that we need to compile the entire Envoy. So this takes quite some time, even on a really beefy machine. And C++, the basic with the specific constraints that Envoy gives you, isn't necessarily the most approachable kind of getting started story for development. especially if we're just trying to build a specific filter that has pretty self-contained behavior. So the Envoy community has been seeing WebAssembly as something that could really change the game. If we could run this WebAssembly kind of runtime inside the proxy, and we could kind of make it train people on how to develop Envoy WebAssembly modules that kind of fit into the filter chain, that could make it much easier. Then people only need to worry about that logic in the language of their choice. So this has kind of initially been introduced as of, in Envoy as an experimental feature. I want to highlight that. Late last year or early this year, we've been very close to development of it. As it was released, we announced WebAssembly Hub, which I'll show in a little bit. But basically, we're kind of helping the community and helping, really push this forward, eager to kind of get this into mainline Envoy, not as an experimental feature, but as kind of a default way to customizing the proxy. To that end, we've got some tooling and we've got this online kind of directory of extensions. And in this demo, I'm going to show you just what does it look like to actually deploy a WebAssembly module to a Gloo installation. Okay, all the setups out of the way. So let me install, actually, let me make sure I don't have Gloo running. Yeah, so it looks like I've got one kind of extra namespace called Splunker. This is a demo application I've deployed. Otherwise, I've got an empty cluster. So the first thing I'll do is just install Gloo Gateway. I'm going to install open source. And the one thing I'm doing is providing a values file. I'll show you what that looks like in a second. So our values file just has a single value, global WASM enabled is true. And this basically, in our Gloo open source Helm chart, this will basically make two configuration changes that are necessary to enable WebAssembly modules. One is setting an environment variable in one of the deployments. More importantly, the second is actually deploying the Envoy image that has WASM support. So this is still experimental. This isn't the native kind of Gloo Envoy wrapper. So you wouldn't by default have this logic. You would need to turn it on this way. And it's worth mentioning for enterprise customers, it still isn't stable enough to be kind of like released as an enterprise feature. But we have been working with some customers and providing builds as necessary. So you can't go and turn this on your enterprise installation today, but if that's interesting to you, please talk to us. We're happy to kind of figure something out. Great, so let me check and make sure that Gloo's installed. Just gonna get the pods. Looks like we've got Gloo running. Everything appears to be healthy. So let's also deploy our demo application and make sure that that is wired up. So this is a really really naive kind of example. This demo application just is a server that will output or respond with information about the request that came in, and we're going to match on just any domain, any path prefix. And let's curl it. I'm going to use the curl syntax here, which is kind of a nesting GlueCTL proxy URL. It's just a convenience mechanism to get the URL for your Gloo proxy. And when I curl that, because I only have this one virtual service matching on any domain, it matches to this route. It forwards the request to our Spelunker service. And as we can see, all that this service is doing is just kind of printing out some information about the request that came in. Cool. So now what I want to do is deploy a WebAssembly module that I can show how it will affect this request. First, let's look at what it means to deploy a WebAssembly module. Because we've already, so in Envoy, we've already kind of provided the scaffolding, the mechanism, the framework in Envoy to know what to do with this image. So really what we need to do is two things. One is we need to provide Envoy the kind of enough information to be able to go find and pull and deploy that filter logic. And it needs a name so we can kind of link it to the filter chain in the Envoy config, and it needs a root ID so we kind of know which module to extract from this just this distributed package. And then we can provide a configuration to the WebAssembly filter. So in our case here, all we're doing is, this is a module that is very dumb. It just reads the request. It actually operates on the response. It will add a response header that says hello, and then provide as a value, like whatever the config that we passed in as a string. So what we're looking for is, I should be able to apply this and then make the same command, and we should see that it's been modified with the new header. I'm applying this to my gateway CRD. So there's two CRDs. The virtual service is where I defined the route. The gateway is where you bind that route to a particular port or a particular listener. So I'm going to patch our default gateway on port 8080 and add just the fact that there's a new WASM filter to add to the filter chain. So I can do this with kubectl patch. Oops, don't want to change that. That will break. I'm using patch 2 actually. So I had a second example with metrics, which we could also use. It's just a little bit easier to see that the add header took effect. So let's run that same curl command. And voila, we see hello world. It's kind of a modification of the response here. And that's exactly what we were looking for, which means that Envoy received this configuration, added this filter to the chain, and this logic actually ran successfully. So that's pretty cool. I would like to just show, while we're here, we do have this website called WebAssembly Hub. I recommend going to it to get a better sense of what's available. And this is a pretty new effort, pretty early kind of in terms of building a kind of a registry of meaningful plugins, but there are some examples, a fair amount of examples from the community. Some, or a lot of them are still relatively simple just to understand the concepts, but would highly recommend, if you're interested, to start playing around with this. And in addition to the hub, which is kind of our, the public kind of registry of these things, that makes it easier to distribute because you can just push to the hub. In addition to that, we also have wasm, which is our command line tooling. So this tooling will make it easy, will help you make it easy to kind of build and publish your modules into WebAssembly Hub, the catalog, and then also it's got some commands to just simplify even the few manual steps that I just walked through to deploy those modules to Gloo. So that's about it for the first demo that I wanted to go through, really just to show what does it look like to deploy WebAssembly module onto Gloo. As you can see, it's really easy. Our example is pretty simple, but there is a lot of power that WebAssembly is going to bring. And as we make it more stable and as it becomes more of a mainline feature, we're really excited to see what the community is able to do with it on top of Gloo. Cool. So for the second, I'm going to uninstall. And the second example that I'm going to go through is a new enterprise, or is a new feature actually of open source or enterprise, but I'm going to showcase it with enterprise Gloo. One of the common bits of feedback that we were getting from users was that they would like to customize the which external auth service was used for a particular route. So up until now, we've had basically a global settings object, and the global settings object contained a ref to your xDauth server. Usually this was just the one that we provide and deploy as part of installing enterprise Gloo, but you could also provide your own custom one. Let me just install. So it's pretty challenging just from a configuration management and an Envoy perspective to support this at the, on an individual route level. It's also, we kind of went back and forth with several different users about whether that was necessary and we ended up finding a compromise, which is it was pretty easy for us to expose it as a gateway option, which means just like before in our WebAssembly example, we'll patch our gateway object. So that kind of controls all the configuration for a particular port, a particular listener. By default, Gloo comes with 2 gateways, one for the standard HTTP port, one for the standard HTTPS SSL port. And then of course you can add your own gateway objects and you can kind of decide which virtual services, so which routes go along with which gateways. So Gloo already had that capability. Now that we can customize which external auth server is used per gateway, we can start to segment traffic to different external auth servers depending on which listener port that the traffic is coming in from, which is a pretty big win for a number of our customers that just needed essentially 2 different auth servers for different business units. So let me kind of make that more concrete and actually go through that example. We should have Gloo Enterprise installed here now. Yep, looks like everything's installed and running. So just like before, I'm going to install our demo application. This will take a few seconds. Basically, Gloo's didn't have any route configuration when it first was installed. So it's detecting this, it's generating a proxy object, and then it's converting that proxy object to Envoy config. But that all happens really fast. We can see the route is already active. Our header that we added from before is no longer there again. That's what we expect. So we're in the same starting point as the last example. This time, I want to showcase what it would look like to route traffic for a particular gateway to a new auth server while not changing our global config. Let me just open up the global settings first, just to show. This is what I was referring to before. This is our Gloo settings CRD, and it kind of provides default global configuration for that installation of Gloo. And as you can see, the default kind of, when you install Enterprise Gloo, you're configuring some external auth server, most likely the one that we ship as part of Gloo Enterprise. What we did is we moved this, or we kind of exposed this config as well on the gateway level, which overrides your global setting. So we're going to leave it as using our kind of Gloo native XAuth server as the global default. But for our HTTP port that's serving this particular route, we're going to switch it over to a custom auth implementation. So let's actually go deploy that. So I'm actually following an example that we have in our docs. We've written this really simple HTTP auth server, and all it's doing is it's checking the path of the incoming request, and depending on the path, either returning a 200 or a 401. It's also modifying the response to indicate that this auth server was hit with a header. So really naive implementation. Obviously, it's not really performing an auth check, but this just shows that, like, the API is pretty general. You can really do a lot of different things with this as an entry point. So first I'll deploy the custom auth server. And then, just as I was mentioning, we're going to patch our gateway object, but this time we're going to patch it so that for this listener, for this port 8080, we're providing this new server ref. I'm also providing this config next to it that says that it's an HTTP implementation. Otherwise, it would be assumed to be kind of a native Envoy gRPC server. And then we'd get 403s. Cool, so I need to patch my gateway object. And now we need to also change our route. So our change to the gateway CRD told Envoy that, or told Gloo really, for any route associated with this listener, when there is external auth turned on in the filter chain, use our new kind of custom auth server. But we also need to turn on auth for the route. So we're also going to change our virtual service to say use external auth. And in this case, we're supplying it just the fact that it's a custom auth server. So it's not one of our native integration, native implementations. And this is just kind of an opaque config block. So I need to go apply that, and then we should immediately see the new config is taking hold. Great, so basically as soon as I apply that and I curl, now I get a 401 unauthorized. And that's what we expect. If we look at what this server is doing, it's sending a 401 to indicate that. We also see that it's responding with a header that indicates that it's performing that Python auth. So this is exactly as we'd expect. According to our server implementation, if I provide it with this path, we should get a 200. I think this was written for our pet store demo, but it should work just as well with the service that I have deployed. So let's try that. So now I'm going to, curl, but to the specific path. And as we can see, we're getting a 200 again. We made it through that auth check, and now we're back to the behavior that we had before. The last thing I'll note, and as a side note, there's a pretty nice integration with Kubernetes directly inside of VS Code if you use that. I just wanted to kind of show, to prove the work a little bit. So our proxy object, which is what I'm looking at now, is this object that we've assembled from all of the configuration that users contributed. So our virtual services and our gateway CRDs that we were editing kind of get assembled into this proxy. And this is a representation of that Gloo holds that exactly gets translated into the Envoy config. So the thing that I wanted to show is just that on our kind of listener, for our SSL port, we don't have an auth server defined here. So it would fall back to the default, which is our built-in native XDOS server. But for this particular listener, we're using the one that we specified. So that's where the patch kind of fits in. And that kind of shows if we wanted to support more routes that hit different auth servers, all we need to do is basically create a new CRD on that port and then bind those routes to it and customize which auth server is being used. Great, so that's it for the second demo, which just to kind of summarize, we now enable multiple auth servers for a single Gloo deployment by where as long as you can specify them at the listener level, you can kind of customize them with a different one on each port. And with that kind of wraps up the content we had prepared. So I'm going to hand it back to Betty. I just want to highlight that a lot of this stuff that we've been talking about, if you want to follow along more closely, just encourage you to use our website, use our GitHub repo, and use our Slack community. We're kind of in there every day and growing that community. So would welcome more participation there.
Great.
Betty, should we do? Oh,
yeah, we have a few questions. The first one is there an order that folks should follow on upgrading, like GlueCTL before the control plane or vice versa?
Oh, yeah, it's a good question. What we've found is that short answer is no. They're like completely independent upgrades. And the only reason it would even matter, like typically I'm only using GlueCTL for the initial installation. We've found that for people that are kind of managing a Gloo installation over time, what they want to be doing is maybe kind of prepping like a Helm values file, or even some combination of Helm and customize to do the fine tuning for the environment. And then usually that's the kind of the source of truth, and Helm is directly used as with upgrade or rollback commands. So that's how I would recommend doing upgrades kind of in practice. but for the purpose of, in terms of what would happen if you didn't upgrade, like GlueCTL by default will use the version of Glue that's closest or that was the latest stable version as of the time of that release. So because I'm using GlueCTL 1.4.5, I knew that it's using kind of the latest enterprise 1.4 and the latest open source 1.4. That was useful to set myself up for the initial install.
And then, with regards to the different versions that we have for Glue, does GlueCTL and Glue system, do those versions have to match in order to work, or do we allow for kind of interoperability in that?
Yeah, it's a great question, and I just want to show a little bit. So the versioning is a complicated topic. I'll try and keep it relatively high level, but short answer is enterprise is usually lagging behind a little bit. So I did deploy the latest enterprise stable release, but it was built on top of an older version, slightly older, but still older version of open source Glue than what I have in my client. But 1.4.4 to 1.4.5 isn't that concerning of a difference. Where we do run into trouble is if there's a significant drift, such that, there's been kind of, we work really hard to make sure there's minimal changes to the API really, and trying to avoid backwards incompatible changes altogether. But just like the wider the drift there, the more likely you might run into problems where there's kind of extra stuff in the CRD definition that either the server or the client wasn't aware of. So I would recommend you try and keep it close, but it doesn't need to be exact.
And then let's see, one thing was a good question that comes up here is like, Glue, you talked about it's a control plane for Envoy. The question here is like, Istio also has a control plane. How do they work together? And this is a very common question we get related to like the gateway to service mesh.
Definitely. Yeah, so I think it's something that we've been, I would start with saying it's an evolving story. So as I mentioned before, we did some work to just like improve the story with the newest Istio release. I think there's some more improvement that we could do, but the state of the world that we have right now is basically Glue will kind of work to, there's a way that you can kind of set it up so that the Glue proxy, the Envoy that Glue manages, acts as the Ingress proxy. And then the set of envoys that the Istio control plane manages are all the sidecars, and Glue's Envoy can talk directly to those sidecars. So in practice, what we're doing so far with deploying Glue and Istio side by side is we're replacing Istio's Ingress gateway with Glue. And it does mean that there's a few more components that you need to have deployed in your cluster. I would argue that it's beneficial, because Glue has a bigger feature set, but I'll also say that that's where we're kind of looking, how can we improve that story? We know that Glue and, we're very close to the Istio development community and trying to like improve that story of Glue plus Istio every day.
Cool. So the question here on like the scaling of the proxies and the control plane, since the control plane is, in our architecture is effectively separate, separate from the proxies themselves. Does this mean you can scale, what are the implications for scale? Like, can you scale the components horizontally or what have you?
Yeah, it's a great question. So fundamentally, Glue is stateless. We don't have like at least when we're talking in kind of, so there's some underlying config store. With Kubernetes, there's nothing to manage, it's just etcd. Otherwise, our customers might have like a console config store. But besides that, all the components of Glue are written to be stateless. So, we should be able to independently manage each one. And that includes Envoy. So if Glue detects that there's 5 envoys instead of a single envoy, then it will push out config via that XDS protocol to all 5 of them. And you can, in a Kubernetes environment, you can literally just change the replica count on the deployment that creates that pod to actually do that. So in that sense, it's like, it's very separate. You know, if you look at some other API gateways in the market, such as Ambassador, it's not as separated. So when it's scalable, but when you're scaling your data plane, you're also scaling your control plane. That has some negatives in terms of how many resources you need to be able to do that kind of scaling.
Cool. And the last question here is related to WebAssembly. You showed, oh, actually, we've got 2 more questions. This one is around, like, you know, you showed installing a WASM module, and it looked relatively straightforward. What if you have to update the module? How do you then apply that update?
Yeah, so that's where like the tooling really comes in handy. And I would, if you haven't yet looked through WASME, which is our command line tool and repo that backs it, would start there. Basically, we've tried to make it easy to build these modules through just a single kind of WASME command. Let me just open the doc, which can show it. So, you know, we've got commands to make it easy to initialize and build features, and then also like push them to our remote registry. One approach that you might want to take is push new versions to new tags. And then when it comes to kind of deploying that new version, you know, independently, you can go into your Gloo config and you can find that patch. You can find that patch and increment the tag there. So changes to the config that I did put into, you know, this patch should take effect immediately. And this just references anything in that public registry. So, and for what it's worth, you know, we've been talking to people about private registries as well. We're just kind of by default using this public one. So yeah, it should look very similar to a standard Docker flow for kind of building images, pushing tags to images, pushing new image versions to either the same tag or new tags, and kind of deciding how you want to manage those.
And then the minute I said, you know, we're just about done with questions, a few more came in. Another question on WebAssembly is there a way to turn off WebAssembly filters for select virtual services?
Yeah, so I believe the answer right now is what you would do in our, basically the same as what we did in our second demo. So because we're customizing this on the gateway level, by default, this is kind of on the filter chain for, you know, as you're kind of alluding to, like on any route in on that listener. So the easiest thing to do would just be create a second gateway CRD, you know, on 8081 or a different port, and put the routes that you don't want with WebAssembly through that. Now, as a side note, if you're kind of managing production traffic, you may even want totally kind of disjoint Envoy instances, since WebAssembly is kind of this new emerging experimental feature. You know, they're actually like, there's a non-WASM and a WASM image of Envoy that we provide. So, you know, it's up to you to decide like your risk tolerance, but you may even want to separate it just, you know, at the actual deployment level with different images.
Great. And then do we have any best practices that we, guidance that we provide on getting high availability in terms of the gateway?
Yeah, I think that, so the short, like definitely like the naive answer is like, you can have multiple replicas, you should have multiple replicas. We work with a lot of customers that ultimately have many different regions and like might be building kind of global applications, and then you're talking about regional replication as well. The devil's really in the details, and we've gotten to the point with a lot of customers where we're really fine-tuning that deployment architecture based on those specifics. So, you know, I think to get from like kind of the basic answer of, yeah, use replicas, and it's really easy. You know, you can do that today with very little change to how you've installed Gloo. But then like, you're probably, that's just step one of a larger kind of thought process around failover and how you're kind of managing, like what you do in the event that one of your replicas goes down or one of your regions goes down. So we do have like an operations guide. This is like a topic that tends to get pretty specific and kind of bespoke pretty fast. So I would really recommend like ping us. We've got expertise to share to help with your specific situation. And then the other shout out is we're thinking a lot about the kind of global Gloo management and federated Gloo management. So I think we will have a lot more to say in terms of features that we are building to make it easier to think about and to actually orchestrate these kind of more global failover scenarios. But that's probably best saved for a future webinar.
Yeah. And then the last question here is an RBAC related question. Are people able to implement fine-grained rollback access control with Open Policy Agent and a way to kind of externalize the rules for maintenance and import them in an automated way? So let me know if we ask for more detail on that, or if that's enough.
I think it's enough. OPA is like my kind of #1 favorite feature of auth actually in Gloo, of our built-in kind of auth implementation, because it's a really powerful language and it runs directly inside of our kind of built-in XDauth server. So all you need to do is define in a config map your kind of rego policy, your actual the enforcement rules, and then Gloo will kind of load that into in memory and run it in the XDauth server. And we've been working with a number of people to improve this. And like integrate with other modes of deploying OPA, but already it's like a really powerful thing that you can already integrate today. Yeah, so to do that, I think. Oh, and then the other thing I wanted to mention is just the development experience becomes really nice once you've got it set up, because all you need to do is go edit your config map, save that to Kubernetes. Gloo will reload that config, into the auth server instantaneously, and then you can iterate really fast. The other thing is, I'll just jump into the docs for a second because I know it's there. The other thing is we've built some logging to make it really easy to see what's going on with Open Policy Agent. So sometimes these policies are pretty naive, easy to follow, but sometimes they're pretty complex, and how they might be evaluated is not necessarily super intuitive. So I think I have an example down here. Yeah, so if you can turn on debug logs, and then we include some kind of commands that you can run to essentially follow all the debug logging, which when you have OPA enabled, you can see the full request, all the inputs, you can see the OPA trace, and then you can see all the outputs. So you can kind of have this going on one tab in your terminal, be editing your config map on the other tab, and it's a really tight debug loop. So yeah, we not only do we have integration, I think it's like one of the best kind of features of enterprise Gloo. Would highly recommend checking it out.
Great. So that is it for us on all the questions. Do you want to just go back to the last slide? Great. So here's some links, folks, to learn more. If you're interested in the open source, we have the link to the project so that you can get involved, make suggestions, requests or file issues, what have you. Slack.solo.io. If you're not already in the community, we have both a Gloo and a Gloo Enterprise channel, and lots of users and our engineers are in there to help answer questions. There's a link to the launch blog in here as well. And then our next webinar is in 2 weeks, and we'll actually dig deep into L4 and L7 network encryption, so you can kind of encrypt the traffic, ingress traffic that's coming in through Gloo. So Rick will be giving that in 2 weeks. I will get the recording and a copy of these slides out to everyone kind of within the next couple of days, and we will see you next time. Thank you for joining.
Thank you.